Hello there and welcome to this Pandas Challenge, day 14 of 30. My name is Valentine and I'll be your instructor. To get started with this challenge, I am going to ask you to visit the description section of this video and then visit the practice resource link that you'll find there, which should take you to a page that looks like what you're seeing on your screen. Once you get here, click on the sample practice resource, which should eventually get you to this particular page, which is just a notebook that we're going to use for the learning or for just going through the different challenges that we're going to be going through in this session. All right, so once you get here, you need to save this copy just save a copy of this notebook. Just go to File, then save a copy, and it should save in your Google Drive, and then we can get started. I'll be using my practice notebook. I won't use the sample notebook. The practice notebook has more challenges as well as just challenges, and we also provide, if you're an after work member, you get access to this notebook, and you also get access to the solution notebook that allows you to verify your solutions to what we have covered. Right, so I'll just open mine in playground mode. You don't need to do that. So once you do that, once you save a copy, go to that copy, and then we can get started. So the first thing that we need to do is to import the Pandas library. So run the first code cell, and this line over here, import pandas as PD, should run or should essentially help you to work with the Pandas library within your notebook. So the first concept that we're going to be going through, it just entails filtering. There are many ways that we could use to filter. So we could use different techniques for filtering when it comes to working with the Pandas library. The specific method that we're going to learn is how to use the lock method, where we essentially create a Boolean mask, or we create just some sort of condition that you can see here. So in our case, assuming this is the data set that we have, and we wanted to just first of all preview it, so we just run this code to import the data, and then later apply the head function to get the first 5 records. So if we wanted to get just records with the yield, when you look at the yield column greater than 5,000, then we can use the lock method, we can use query method, we can use ilock. There are quite a number of methods that we can use. But just to learn how to use the lock method and practice it more, we would define our condition where we specify the column and use an operator as well as the number that should essentially altogether give us a condition that we want to check. So we want to get records with this condition being true, with yield column greater than 5,000. And we save that inside the condition variable, and then we pass that to the lock method. And essentially what we get would be the filter data that that contain this condition as true. And that's it basically. So that's what we've got. Pause the video and then work on the challenge. We've got a challenge here, so pause the video and then work on the challenge. Again, the sample notebook is similar to the practice notebook. The only thing is that the sample notebook doesn't have all the challenges. And if you want more challenges, be sure to become an afterwork member. You'll get all the resources that you'll need. All right. The next thing that we need to do is to filter columns with the here we have gotten to have learned how to filter for records with the rows, filter for rows with the lock method, but we can also do the same thing with the columns. So assuming that we have this data set that we have here, so first of all, I'm going to reload again a new data set that contains farms as well as just yields, slightly different from what we had here. And we wanted to select, say, columns, specific columns. Yes, the records that we wanted, but we could also specify the columns that we want. So assuming that we wanted to select all the records, but now specific columns. So we wanted to get farm ID, maybe crop type, not location, but acreage, yield, as well as the weather condition. Then we can specify that inside the lock method. First of all, we the first thing that we define here is that we want to get all the records for those columns. So we use a double colon, then comma. So whatever comes here initially will specify the records that we will get or be returned, then comma. Then we pass now a list, or we define a list of column names that we would want being previewed. And that's it. We store now the data with selected columns inside selected columns variable, and then or data frame, and then we print out the first 5 records for that data frame. Right, there you have it. Pause the video and then work on the challenge. We can also perform advanced filtering using the query method. So the query method is another method aside from using the lock method or ilock method that allows us to be able to filter for records. So if we have this data set that we see here and we wanted to get records, so this is the data set that contains, again, just farms, but this data set contains maybe it could be that we want to get only farms which have which grow vegetables and have are bigger than 10 acres inside. So this is the acreage. So we could get this record is one of those. So it's a farm that has vegetables, it grows vegetables and has 75 in terms of acreage value. So generally, assuming that we wanted to do that, we can use the query method. We apply it to the DF data frame, and inside the query method we specify a condition or conditions. So the first condition here, if we wanted to specify just 2 conditions, we would specify it as shown. The column name, if it's a column name that has more than 2 words or more than 1 word, we would enclose it in delimiter characters, as you can see here. But if it's just 1 word, as you see here, acreage, we don't have any special characters enclosing that column name. So here we enclose that, and we specify equal to vegetables, and acreage is greater than 10. That's it. And we filter for data as such. And you'll note that this, I don't know, I tend to prefer this method because it's a bit easier. It also just makes it, you don't have to think so much about how you would write everything in terms of the proper way of writing the conditions or the syntax. You just use whatever that you have, and that's it. So this is what we have. All right, pause the video and then work on the challenge. Furthermore, we can also use another technique called is-in technique to be able to get records or filter for records that contain a certain value. Let's say, for example, you wanted to get maybe a record that contains the value 75 or the value location. Then we can use is-in. Is-in works really well when it comes to extracting records that have some string data. So if your condition if your condition has some sort of a value that is string in nature, it works well. Even values themselves, exact values, it still works well. But when it comes less than or greater than, you could just use Boolean indexing, or you could use a lock method, ilock method. You could also use query method for that. Okay, so let's load this data set that we find here. This is the data set. If we wanted to maybe define, if we wanted to retrieve records using now the is-in function, so we would first of all define a list that would contain the values that we want. So we want to retrieve records that have specific type of, that have a specific location. So let's say we want records that have California, so which would just be farms in California. We can first of all define a list that contains the values that we want, and then we pass that list to the is-in function that we apply to the location column, which is the one column that we want to check for this condition for. So yeah, so this is what we do. We define that list of location, and we can have multiple of them, but we will see that later. So once we do that, we define inside the df data frame square bracket, we define the location, then we apply the is-in. We define the column, then we apply the is-in function to that particular column, and we pass now the specific locations or values that we want to check in that column. And that's it. We get the filtered data. Right, pause the video and then work on the challenge. In some cases, like here, if you wanted to just get more records, not only in California, but maybe in Nebraska, we just need to put an element, a second element inside that list. So like, for example, in our case here, where we have, again, we have also these factories. So not farms now, we have factories that we see here. And we wanted to get maybe, we wanted to create a list of values to filter. So we wanted to get maybe New York, maybe San Francisco records that have for location, New York, then San Francisco, then we can define a list as shown. This is also, this approach that we're going to learn also allows us to use other approaches. So Boolean indexing, we can also, with Boolean indexing, we can also use different approaches to selecting our data, so, or defining the condition. So here we are also defining a different condition. So here we are technically using the is-in condition as well as Boolean mask that we have on the right hand side, and we're enclosing them in parentheses as you see here, and using an and ampersand, the and sign or ampersand to join them and say that we want to check for both conditions, and then we print them out. All right, pause the video and then work on the challenge. All right, so moving on, deleting a row in a data frame by index. So sometimes we might have a way of identifying the record that we want to delete within a data frame. So, and that could be using the index. We might have that identifier. So in order to delete that particular index, we can use the drop function. So assuming that this is our data set that we have over here, and we wanted to delete the record that has the index 5. So this record that you see here, how we can be able to delete it, we just use the drop function, which we apply to the data frame that we want to delete the record from, and we pass that number. And that's just generally it. We could decide to do this and store that in df variable. We could use the in place parameter. Both ways work. So if we run this, we should be able to see that we don't have in our new data frame the record. So the one that has 5, index 5 is no longer there. Okay, right. And by the way, in some cases where you might have maybe a common identifier, another common identifier such as farm ID, you can index that particular column. So you use that as an index, and we've done that in a past challenge, so you could always just go through that. Right, moving on, sorting by multiple columns. We can decide to rearrange the data that we have in order to answer specific research questions. Maybe what was the top most performing product, or what was the most expensive products, and that's where sorting comes into. So one of the techniques it's an advanced technique that entails sorting, that we might come across would be sorting by multiple columns. So assuming that we have this data set that we have here, we could decide to, let's wait for the data set to load, which it has. We could decide to sort the records by crop type. So having the crops, the records with the crops that have that appear alphabetically first when it comes to the crop type, we can have them come first, and the ones that come afterwards, maybe Z, come later. We could decide to first of all sort the records by that, and then later onwards, once we have done that, we could then decide to for those records that share the same, say, category of, let's say, crop types. If it's fruits, we have 3 records with fruits. Then we can then sort those records by now another variable like total production, and that's actually what we're doing here. So we are sorting the data frame using the first of all the crop type column, and then later the total production column. And that's it. The outcome, as you'll get to see, we have our data set sorted. We have apples, apples, apples. And then when you look at on the far right, we have total production, but the records for apples have been sorted. So we have total production, they're sorted in ascending order from total production from low to higher values. Yeah, so apples, apples, yeah. Something to note is that we can also include the ascending parameter that will contain true or false values. I think we've also covered that in the past. So yeah, so that is something that you could also add, but here by default, both values will be sorted in ascending order. Right, pause the video and then work on the challenge. We can also decide to iterate over data frame rows. This is a challenge concept that we've covered in the previous challenge. So we could decide to iterate through maybe the records that we have in our data frame. Maybe if we want to do something with regards to the records themselves, like each record, maybe add or check for condition, etc. Yeah, so there are many use cases, special use cases. So for example, in our case over here, we are sorting through this data frame, and we do that by using the iter rows. Okay, we use the for loop method first, and we define the variables that will contain the current items, so or the current records. Index over here will simply contain index over here will simply contain the index of the record. Row will contain all the contents for the columns within that record, and we can access the values for those columns as shown here and store them in the respective variables. And to iterate over the data frame records, we use df.iterRows, which should get us now the records themselves. And yeah, we iterate, and in each iteration we're just printing out the farm ID, crop type, acres owned, the rest of the information as well. So if you run this, you should be able to see our iteration over each and every record. Pause the video and then work on the challenge. We can also, in some cases, identify outliers in order to just be sure that our data set is reliable. Or we might also want to identify outliers so that we could use them to answer some specific research questions. And this is where using a box plot comes in. So we could decide to, first of all, load the data set, explore the data set that we have. And then once we have done that, we could use the plot function. We apply it to the column that we want. We select a column that we want. We're interested in the yield column. Maybe that will give us some useful information about the particular farm that is here. It could be an outlier. So in our case here, we could use that to be able to get the outliers. But now here we're just getting the outliers within this column, the yield column, and you can see there are a few outliers. Some have values closer to 8,000, 7,000, but the majority of points that we have in this column have records between 3,000, around 3,000 and something to around 4,000 and something, a bit more than 4,000, right? By the way, if you wanted to now, this just gives us some visual perspective, but if you wanted to extract or get more information about those records, we can then use other outlier detection methods such as the IQR method or the z-scores method. All right, pause the video and then work on the challenge. We can also, in some cases, decide to apply some custom function to, to some existing column in order to create some new data. So assuming that we had this data frame that contains information about factories, what we can do is maybe we wanted to determine the production capacity here. So we have production capacity, but this could be in tons, but we wanted to have production capacity in kilograms. So we could decide to create a new column that contains that, but the process of creating that new column would require us to create a function or write some code that performs that conversion, and then enclose that code in a function. So the code that does that is what you see here, tans 907.1 and 5. So we multiply tans times that. Tans is the existing value for this column. So what we end up doing here is that we are applying this function to the production capacity column, and essentially storing the resulting values to this particular new data frame called production capacity kg that we will get after. This might be useful for analysis if you have research questions that require you to answer questions in this particular manner, or in some cases where applications require values to be converted in order for them to give some meaningful output, then that might be important. So yeah, so that's what we do. And then we just preview our data frame. So if I run this and preview now our data frame, you can see production capacity kg on the far end. It's important to note that you can still re-index these columns so that you have the column names appearing in the structure or in the manner that you have. Maybe you want production capacity next to the what you have here. You can also rename the columns if you want. Pause the video and then work on the challenge. Alright, so that's it with regards to this challenge. I hope you learned a lot, or you were able to refresh on some of the concepts that you might have not, or you might have not really grasped in the past. If you did love, the learning experience, and you'd want us to continue doing what we've been doing in terms of creating more of such content, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future courses or videos, be sure to subscribe. All the best in your learning journey, and see you in the next challenge. Bye bye.